So we're going to deal with redox. For some of you, it might be a new topic, but for the good there, I don't think it's a new topic. Now, redox. Redox.
It's what?
Redox.
Redox.
I've never heard about it. It's okay. Redox stands for reduction and oxidation.
Right. What do you spell redox? Oh, okay.
Can you all see my whiteboard? Oh, I haven't shared. If I shared my... Huh?
Yes, sir.
You can see?
Yeah, we can see.
Okay.
So it's reduction of what?
Reduction and oxidation. Redox is reduction and oxidation.
So this iPad person is not connecting to the audio.
Sean is not connected.
Hmm?
I thought you were speaking now. It's not connected.
I don't know if it's shown or not.
No, it's Sean. iPad.
Oh.
Sean, can you hear us?
Reduction and oxidation.
Sean, can you hear
Can't
us?
hear anything. He can't because he hasn't connected to the audio.
Sean, can you hear us?
Nope, he cannot.
Wait, send him a message on the chat.
Okay.
Won't he get that?
Okay, I'm sending him. But I'm not sure why he hasn't connected his audio. Unless he just left his thing there.
Maybe he doesn't know.
So let's start with the first definition of oxidation. Maybe I'll do this. Let's have oxidation this side, and let's have reduction the other side. So the first definition.
Are we making a table?
Yep. Maybe sort of. The first definition for oxidation is that oxidation is the gain of oxygen atoms. The gain of oxygen atoms is oxidation. So for example, if your sodium metal, if you leave it exposed to oxygen, it will react with oxygen at room temperature and form sodium oxide. Okay.
Of oxygen atoms.
So you see, sodium has gained oxygen atom. So sodium has been oxidized because it has gained an oxygen atom. So you can write that sodium has been oxidized because it gained an oxygen atom. Sodium has been oxidized because it gained an oxygen atom. Clear?
Yes.
Now, let's look at reduction. Is the opposite of this. So it's the loss of oxygen
particle
atoms. Okay. In this, if you use the same equation, okay, this oxygen molecule, the O2 molecule, this one, O2 molecule, has lost what? It was 2, now it's 1. It has lost an oxygen atom. So the oxygen molecule, when reacting with sodium, lost one oxygen atom. So it has been reduced. Are we together? It has been reduced. Oxidation is the gain. Is Tashana there? Who was joining just now?
Yeah, it's Tashana.
Are we together? So oxidation is the gain of oxygen atoms. Reduction is the loss of oxygen atoms. So in this example, we have said sodium has gained an oxygen atom, so it has been oxidized. The oxygen itself, the molecule, has lost an oxygen atom, so it has been reduced. Clear? Another example where we can apply the first definition that we have talked about is to deal with magnesium. We react a magnesium ribbon with oxygen, it reacts to form magnesium oxide, 1:1.
Is this another example for what?
For the same definition. Now,
oxidation or
2, yes, oxidation and reduction. Oxidation and reduction here is, look at this. When something is oxidized, something is reduced. That's why it's called redox. They always happen at the same time. When there is oxidation, there is a reduction. That's what I want you to get now. So look at this. This magnesium has gained an oxygen atom. So we say magnesium has been oxidized. Yes, magnesium has been oxidized. Why? Because it gained an oxygen atom. Yes.
Atom. Dude, I started lessons at 6, dude. What do you expect?
Then, what can you say about this oxygen molecule? Jordan, what happened to this oxygen molecule? It's 2. Now it's only 1. So it has been reduced. So the O2 molecule has been reduced. Reduced.
Put my new AP in the water like a boat.
Because it lost one oxygen atom. So that's the first definition that we're looking at. Oxidation.
Wait, how is there the term hydrogen in any of these definitions?
Yeah, we'll
like, can you say?
We'll look at that. There's nothing hydrogen there. We can't use it. We'll use it when it applies.
Okay.
Don't worry about that. Now, why are you waking up at 6?
I wake up at 5:30 because I have to join Mr. M's lesson. They start at 6.
Yeah. Well, he likes early lessons. Now let's look at the next definition of oxidation and reduction. Tashana, are you there? I thought you said Tashana is there. Why is she quiet?
Yeah, she's there. Tashana is always quiet.
Loss of hydrogen. Can you write that down? Loss of hydrogen.
I'm blessed and you're not.
Loss of hydrogen atoms. And reduction is the gain of hydrogen.
That is just greatness personified.
Atoms. Now we're together?
Yes, sir.
Yes, sir.
Oh, you are lost.
Because there's lost.
Oxidation is the loss of hydrogen atoms, and that one is the gain of. So let's look at an example. If I have C.
This is what I was asking, Mr. K.
CH3. The equation that we're doing was there any hydrogen on that equation that we're doing?
I was asking.
And
I said, is there any way
I answered
What
you,
did
and
you
I
say? You
said, we'll look at that when we're looking at where it's involved, hydrogen is involved. That's what I said. When there's nothing to do with
Yes,
hydrogen,
Mr. K.
I answered you properly.
Okay.
So what's happening there? If you look at this, it's not a full reaction. We just want to look at this. What's happening? Haven't we lost one hydrogen here?
Yes, sir.
So that's what? Oxidation.
Yes, John, this is oxidation.
Now we're together there.
If
If we look at the
Yes, Mr. K.
opposite, so if it was the opposite, this going to that, that's reduction.
One, this is a question.
Reversible reaction. Are we together there?
Yeah.
Now let's look at the next one now, which talks about electrons. Then reduction. This one now, before the definition, I have to explain, because that's the one that confused many. Now, oxidation is the gain in oxidation state. Oxidation state. Then reduction is the loss in oxidation state. Oxidation, gain in oxidation state.
The oxidation state.
Reduction, the loss in oxidation state. Now let's look at some rules. So you need to know certain rules for oxidation. Rules for oxidation. Number one. The overall oxidation state for any element, molecule, or compound is 0. Are we together? Overall oxidation state for any molecule is 0. Element or that. Are we together there?
Yes, Mr. K.
So if we look at this, sodium has got an oxidation state of 0. Magnesium has got an oxidation state of 0.
Two devices are connected.
Are we together? Oxidation state of 0. Then if I look at oxygen, the molecule, not one oxygen atom in this molecule, the molecule itself has got an oxidation state of 0. If I look at sodium chloride, the oxidation state, because we said every compound, the overall oxidation state, but not the sodium ion, where I'm talking of the overall oxidation state of sodium chloride is 0. But I said every compound, every molecule, the overall oxidation state is 0. Okay. We'll look at questions then to make sense just now.
Yeah.
Now, the next point or next rule is that group 1 ions, yes? Your question?
I disconnected, so I like missed that whole page.
Okay, it's fine. You get it now. As we explained, we're talking about oxidation and reduction. Oh, we have lost someone.
No, Jordan had two devices connected.
So group 1 ions.
The same one, but I don't know.
Let's write this. Group 1 ions have an oxidation state. Ions, not the
What are we doing now?
Oxidation state of +1.
Yes.
All group 1 ions have got an oxidation state of +1. Are we together? So if you look at lithium, +1, like this, sodium plus, that's why it means +1. They've got an oxidation state of +1. All group 2 ions.
Let's talk business. All group 2 ions.
Yes, sir.
Have an oxidation state of +2.
Oh, okay. Oh, okay. Yeah. I get it. Get it.
Plus 2. So the common examples: Mg 2 plus, calcium 2 plus,
Na2 plus.
barium 2 plus. Are we together? Then all group 3,
One
all
is a
group
smart
3
man.
ions
Of course. Tell me
have
something I don't know.
an oxidation state
You're an idiot. That's what you don't know.
of plus 3. So we have aluminium 3 plus. Okay. Are we together? Oxygen, this is important now. Oxygen has a minus 2 oxidation state. The oxygen ion, not the molecule. The oxygen ion has got an oxidation state of minus 2.
The what?
Oxygen ion has got an oxidation of
Because it's in
minus
group
2. Group 6. Oxygen is not group 6.
Group 6.
There's an exception, except in hydrogen peroxide. Hydrogen peroxide, which is H2O2.
But that one
So
doesn't have a group.
This one, the oxygen ion has got a minus 1 oxidation state. Are we together? So oxygen always has got a minus 2 in any compound that oxygen is. That's what we mean. In any compound that oxygen is bonded to, it will always have a minus 2, except for hydrogen peroxide.
Peroxide.
Okay.
Epi in the water. Oh.
Now group 7.
Yeah.
7
Group
ions have an oxidation state. We've lost someone of minus 1.
No.
I thought someone was leaving.
It's Shokuzo.
That sound. Is that Shokuzo?
Yeah. Oh yeah, he's back now. He's just confused.
Okay.
No, it's Shokuzo.
Are we together there? Group 7 ions have got oxidation state of minus 1 because they always accept 1 electron. Are we together? Then let's look at transition metals, some transition metal ions that we need to know.
Okay. Iron.
So we have copper 2 plus.
2 plus.
Then we also have copper plus, depending on what. But in most of your chemistry,
depending on what?
Depending on what it's bonded to. But this is the most common one. Then we have iron. Iron has got 2 oxidation states. We have iron that and
2
iron 3 plus.
3 plus.
Then zinc, only 1 oxidation state.
2 plus.
Then lead, only 1 oxidation state. Silver, 1 oxidation state. Are you together there? I'm giving you the common ones. Then the ammonia ion, NH4, positive, like that. Clear?
Yes, sir.
Then some. Okay, that's what you need to know for now. Now, let's apply this now to some chemical equations. And then we deduce which one is oxidized, which one now. Then we look at ionic equations. Now, let's start with this simple one. Hydrogen plus, if hydrogen reacts with chlorine at room temperature to form your table salt, sodium chloride. Okay. Like that.
Wake up in the morning, I have breakfast on my mind.
Now, let's look at this Tashana there. What is the oxidation state of this sodium from what you say? What is the oxidation state of this sodium? Who can tell me from those rules that we've just said?
Okay, let me check it out.
1.
What is the oxidation state, Tashan? Are you there? Tashan? Is something wrong with the audio or something? We can't hear you.
She's just quiet.
Huh?
He's just quiet. Smart but quiet. Unlike Rukudza. Doesn't
No, I
know.
think
Shut up.
What's the oxidation state for? That's Na2 plus for oxygen.
no, this is sodium.
Oh, yeah.
So what's the oxygen state of
Na2.
sodium? Or what's the oxygen state of this sodium?
2 plus. That's 2.
How can it be 2 plus? What's the oxidation state?
1 plus.
It's not 1 plus. It's wrong. What did I say? I said every. Go back to your rules. What's the first rule? Every
it's got
atom,
zero.
every element, every compound has got an oxidation state of 0. This is not an ion. It's just a sodium element. It hasn't reacted with this. So it's 0.
Okay.
The oxidation state of chlorine here, it's a molecule. It hasn't reacted with anything. It's 0. That's the first rule. Every atom, every element, every compound has got an oxidation state of what? Of 0.
0.
When it reacts with this ion there, it now forms the ion, this sodium. So now I am interested in this. What's the oxidation? So the oxidation state of this overall is 0. But I'm interested in this sodium ion. What is the oxidation state of that? What do you say about the group? This is a group 1. So what's the oxidation state? This is just balancing the equation. It doesn't affect oxidation states. What's the oxidation state of, what did you say about group 1? Go and check your table. Maybe it's new to you. We said this what? Group 1 metals always have an oxidation state of what? Ion. I said that. I think that was, what did we say, Mr. Alkuzo?
Is my mic on mute or something?
Yeah, I can't hear you. It's +1.
I said,
so we said the definition of oxidation is the gain in oxidation state.
Oxygen.
It has gained from 0 to +1. So this is oxidation. Now, what is the oxidation state of chlorine group 7? Go and check your table. It tells you that it's -1. -1. So it's from 0 to -1. This is a reduction.
Yes, Mr. K.
So chlorine.
So do you understand it?
Sodium.
Yes, shut up, man.
Chlorine has been.
Pardon? Mr. K.
Sodium has been. Yes. Your question?
Are you going to send this recording on the group? Because I've missed a lot of notes.
Yes, we are actually recording. Yes, we are recording. The lesson we are recording as we are going. We are actually recording the lesson. Now let's.
Why doesn't it allow me to record?
Let's look at another example. So you need to understand those rules that I gave you there. Now let's look at magnesium. Can you stop writing on my? Use the note when writing on my whiteboard. Okay.
Obvious condition.
Magnesium oxide. The same that we looked at.
Laptop, I can read it.
Okay. Are we together there? Okay, guys, can you pay attention? Now, what's the oxidation state of this magnesium?
0.
Yes. Because it's simply an element. It hasn't reacted. But now it's an ion now. It's an ion. It has reacted. What's the oxidation state of this of magnesium? It's group what? Check in your. It's group 2.
Is it 2? Is it yes. 2 plus?
Plus 2. What 2 plus?
Plus 2.
Like.
But that's how you say it. But that's how they say it. They say 2 plus.
Yes, it's correct.
It actually.
It's correct. Are we together? To say 2 plus. Now, what has happened there?
That's oxidation. Yes. An increase in
oxidation state. From 0 to that. Now, the oxidation state of this one is 0.
It's 0.
But now it's now an ion. It's minus what?
So -2.
Yes. So what happened to this oxygen? Reduction.
It was reduced.
Now, but there's something that we now want to introduce. The one that is being oxidized is a reducing. Don't get confused about this. It's a reducing agent. Are we together, Tashana? It's a reducing agent. Why? Because it's the one that is reducing this oxygen to that. So we call that a reducing agent. The one that is oxidized is known as a reducing agent. And this oxygen is known as an oxidizing
agent.
Why? Because it's the one that is oxidizing this magnesium.
Yes, sir.
So in general, let's write that in general, that is not always the case. In general, metals are reducing agencies. Metals are reducing agencies. And group 1 is the strongest reducing agencies. Group 1, the strongest reducing agencies. The non-metals are oxidizing agencies, and group 7 has got the strongest. Non-metals are oxidizing. They oxidize things, oxidizing agencies.
Are you sure you understand, Sean?
Now let's look at another example which does not involve, which involves metals, a displacement reaction. Because the other metal is more reactive, then we apply our rules, just what you're talking about now. So if we have copper sulfate plus zinc, because zinc is more reactive than copper, it displaces and reacts with the copper sulfate. So we have zinc sulfate plus copper, like that. Zinc sulfate plus copper. Now, let's look at what happens there. So this copper, you see copper is an ion there because it's bonded to sulfate. It's copper 2 plus. Huh? So the oxidation state is plus, like what you're saying, 2 plus or plus 2. Then this oxidation is what? Is 0. Was just an, can you see that? So what has happened here? Reduction. Then this zinc is 0 oxidation state, but now it's bonded, it's plus 2. What has happened? Oxidation.
It has been oxidized. Okay.
So
okay, get it. Yeah.
This is, can you see that? What can we call this one there? If this has been oxidized, this is the reducing agent. Because it's reducing that. So it's a reduced zinc now. In this reaction, zinc is a reducing agent. And which one is the oxidizing agent in that reaction? Which is oxidizing this? It's the copper sulfate. This is the oxidizing agent. Are we together there?
Yes, sir.
Now let's look at, introduce now what we call half ionic equations. Half ionic equations. Now they have, think of this copper. What's happening to this copper? This copper is a copper ion 2 plus in this solution. This copper, remember, if it's 2 plus, it means it has lost 2 electrons to this sulfate. But for it to go back to this, it actually gains 2 what? Electrons. Just to gain 2 electrons to form copper. That's the first half ionic equation of what's happening there. Are we together? Think of this zinc metal. It has to lose 2 electrons. So in chemistry, in your books, you never see this. I'll explain why. It's minus 2 electrons because it's losing 2 electrons to copper 2 plus. But they move this so that it's a plus 2. That's the convention. But to write this, but in your books, they don't like this convention, but it's correct. So they write it like this. Okay, are we together then? That's what has happened. So zinc has lost 2 electrons to form zinc like that. So this is the second ionic equation. This now is what we call a spectator ion. Because nothing is happening. This is simply S242 negative.
Mr. K, may you please just repeat how you did that copper that copper one, half ionic equation.
Copper 2 plus from this was an ion. If it's copper 2 plus, you know that from your that if it's 2 plus, it means this copper has lost 2 electrons to this sulfate. So it's copper 2 plus. It has 2 less, it has 2 more protons than electrons. Huh? So it has to gain 2 electrons to form a copper metal again. That's what's happening. Remember, we said oxidation is the, remember what we said there, according to your definition, gain in oxidation state, reduction, loss in whatever. Okay, like that. Okay, are we together then? Make sense?
Okay.
Reduced like that. Okay. So it's gaining 2 electrons to form that. Then this zinc metal is just reacting like a normal metal. It's giving away 2 electrons. Are we together then? To form that. So where is, Tashana, where do you think this copper is gaining the 2 electrons? From the zinc. Like that. Okay, anyway. Now we balance these equations. We write what is called a balanced equation. Okay, I'll use this space. I'll wrap this. Then there's space below this. So let's write the balanced equation. Now, balanced equation, look at this, Jordan. Do 2 or more. Oh, it's now time for the next subject. And you guys are quiet.
Yeah.
So we cancel the electrons
I don't understand because you're like,
like that. We
Shut
cancel
up, Iwe.
the electrons. Are we together? When we cancel the
Look
electrons,
what's Quran
then
and
simply add the equation. So we'll continue this topic next lesson like that. So we are simply adding the left side. We cancel the electrons, they cancel. Then we form copper plus zinc 2 plus. That's the full ionic equation. Okay, we'll continue from that. Can you log on to the geo lesson?
Goodbye, guys. Stupid records. See you later.
Shut up, man. Right.